It is, I guess, 6:14 a.m. on Wednesday morning, and we're going to start our Unit 11 for Pre-AP Unit 12 notes on 5.1. So we're on 5.1. And 5.1 entails using fundamental identities. Two just notes, and then we're really going to go straight to examples today. I have 7 examples for you. They are quite entailed, so you're going to really have to pay attention. You may want to not take notes at first. You may want to just watch them and then go back and take notes, or you may want to pause a lot and take notes and think about what's happening in these problems. These 7 examples are examples I would have for the rest of this unit, even when we get to 5.2 and 5.3, because all of this builds up to that. This is like the major step, I would say, the biggest step in solving, and eventually we're going to get to solving, and this will be your first step to solving. It's sort of, I'm going to equate it to, if you're solving a quadratic, it's the factoring part. Okay, so you get to the factoring part, you do all the stuff that leads up to factoring, and then solving is not such a bad thing. And the same thing here. If you really get 5.1 well, then it'll help you with 5.2 and 5.3. All right, the identity page that I handed out, I need you to make sure that you have, get that back out on your desk today, and maybe even right now while you're taking your notes so you can refer to it. And you're going to have to make sure that you've memorized the left side of that page, the left side of that identity page. And then we're going to use those identities to find our trig functions. All right, so let's go ahead and get started with example 1. So go ahead and get your pause and find your worksheet. Our first example is we're going to be given 2 identities, and we're going to be asked to, and a restriction, and we're going to be asked to solve for the other identities. And these are, we've been doing this, so it's going to feel a little similar, except we're going to be using a lot more of the other identities. I'm going to write these down, and I'll be right back to you. Okay, so we're given that tan theta is 2, and we're giving that sine theta is less than 0. So first of all, let's figure out what quadrant we might be in and what information we know. We know if tan theta is 2, that would be 2 over 1. Using our identities, we know that tan is opposite over adjacent. And it says it's positive. So let's go over here, and I know some of this is going to feel familiar, and it should, because you should feel like we're using some of the things you've already learned. Since tan is positive, we would be positive in the first and the third quadrant. Remember our little all surfers to California. And this says sine theta is less than 0. That means sine is negative. Well, sine would be negative in the third and the fourth quadrant. So we must be in the third quadrant. So let's go ahead and draw our triangle in the third quadrant. I'm going to erase those little check marks. I should have made them down here at the bottom. It makes it a little easier. You don't have to redraw another triangle. So I know that's where I am now. Okay. So my triangle is going to be here in the third quadrant, and this is going to be my reference angle. All right, so it says tan is opposite, so from theta, opposite would be 2, adjacent would be 1. Now, be really careful. That would have to be a -1 and a -2, because negative and negative together would have been a positive. So remember, tan is positive because sine and cosine are both negative, and the 2 negatives would make a positive. Be really careful about your negatives and positives. All right, so we want the other identities. Well, if we have tan, we immediately have cotan. That's easy. You would flip it over and have 1/2. These are reciprocal identities. If we want to use Pythagorean Theorem over here, we would have, this is a leg, and of course this is your hypotenuse. So we'd have -1 squared plus -2 squared equals hypotenuse, or we can call it the radius squared. That would be 1 plus 4 equals r squared. That would be 5 equals r squared, and r would be the square root of 5. So the radius is the square root of 5. If you're having trouble with Pythagorean Theorem, and a few of you did on the test before, you do need to make sure that we clear that up as soon as possible. All right, so now we have cotan, and now we want secant, or we want sine, theta, we want cosine, theta, Let's go ahead and do those. So sine theta would be opposite over hypotenuse, which would be negative 2 over the square root of 5. And you know that we need to rationalize our denominator. So we'd have the square root of 5 and the square root of 5. So we'd end up with negative 2 square roots of 5 over 5. So that would be an answer. For cosine, we would have adjacent over hypotenuse, which is negative 1 over the square root of 5. Same thing, rationalize our denominator. And we'd have negative square roots of 5 over 5. All right, and then sine goes with cosecant. Now, here's a little trick so you don't have to do a lot of rationalizing again. Go back to your original value of sine theta, negative 2 over square root of 5, and flip it upside down before you rationalized it, and it'll already be okay for you. So that would be negative square roots of 5 over 2. And the same thing we'll do with secant. We'll go back to the original, and we would have secant theta is negative square roots of 5 over 1, which is just negative square roots of 5. And there we have it. All right. Just wanted to let you know where we were. We were in quadrant 3, and that would be example 1. Okay. The next example is sine negative x equals negative 2/3. Remember, when you see a negative value in there like that, you've got to think of odd and even functions. If you remember, sine is an odd function. Look at your identity page. That will help you. If you're looking on that identity page, you'll see odd and even functions on there. Sine is an odd function, and therefore it is opposite. So that means when the x value is positive, the output is going to be opposite of when the x value is negative. Think about that again. When the x value is positive, it's going to have an opposite sign as when the x value is negative. So had the x value been negative when they're negative x, then the positive will be positive. If the negative x value had been positive, then the positive value x would have been negative. So the output would have been opposite. So let's just go ahead and do that. So we know that sine x is equal to positive 2/3. And that's what we're going to build everything on. That makes it a little bit easier. All right, immediately, since we're trying to find all the 6 trig identities, we immediately can go ahead and do cosecant x. That would flip over and be 3/2. So we've got 2 of them. We also have another piece of information. We also had that tan x was equal to negative 2 square roots of 5 over 5. All right, so we had some other information. So we're going to use this and this together to figure out what quadrant we're in. All right, and I'm going to put my little all surfers to California here. All right, it says, so we know that sine x is positive. Sine would be positive in the first and the third, or second. And it says tan is negative. Well, tan would be negative in the second and the fourth. So here's our 2 check marks. So our triangle will be built in the second quadrant. So we have a second quadrant triangle, and let's go ahead and set up our problem. I'm going to go back and use my sine value to set up. I think it'll be easier than using all this tan value. We know sine is opposite over hypotenuse, so from theta, opposite would be 2. That's a positive 2, and the hypotenuse would be 3. Now, this side right here, let's think about this, make it easy for ourselves. Tan would be opposite over adjacent, and you're thinking, why do they look different? Well, that's because we have to calculate that division before and rationalize our denominator. So I'm going to guess that this 5 is not maybe the adjacent side. Let's see what happens Pythagorean theorem. So we're going to go 2 squared plus 3 squared equals, oh, messed up. And some of you did that on your last test. 3 is the radius, so we're going to have 2 squared plus the missing side squared. Since it's the x value or the cosine value, I'm going to call it c squared equals 3 squared. So that's 4 plus c squared equals 9. And then we're going to have c squared equals, we'll subtract 4 equals 5, and we'll take the square root, so c is actually the square root of 5. So you have to be really careful when things have been rationalized that you don't just take them for their value. So this isn't quite true in this case. So that would be if everything was on a unit circle. This radius is longer than that. So we have the square root of 5. And then the other thing we have to be careful of is what kind of square root of 5 would that be? It's if you were just going from the origin to the left, you know that would be a negative value. So now we have everything set up. I think it'll be easier than taking the reciprocal of tan to find cotan by just looking at our triangle. So cotan x is adjacent over opposite. If you need to keep writing those letters, do that. That'll help keep you straight. So from here, adjacent would be the negative square root of 5 over opposite, which would be 2. And that would be easier than flipping this one and rationalizing it. So there's our cotan value. And now we're left with cosine and secant. Again, looking at our triangle. Cosine is going to be adjacent over hypotenuse, so negative square roots of 5 over 3. And secant is going to be that reciprocal, and in this case we will have to flip this one above and rationalize. So we'll have negative 3 over the square root of 5, rationalize the square root of 5, the square root of 5. So we have negative 3 square roots of 5 over 5, and that would be our other answer. There you go. Go Bearcats. Okay, now we're into simplifying some trig functions, and we're going to make them a little bit simpler. Here we have cotan x over cosecant x. When I see a big fraction bar like this, I'm going to think division, and so I'm going to write it as old-fashioned division. I'm going to write it as cotan x divided by cosecant x. And then I'm going to, I've said this before, I'm going to change one thing at a time. One thing at a time. I may have to change both, but I'm going to do one at a time. I'm going to change cosecant first. I know cosecant is the same as 1 over, and I'm going to pause for a minute, see if you can mentally know what that is. Cosecant and sine are buddies, so it's 1 over sine x. And then I think, then I'm thinking, what could I change cotan to that might have a sign in it so I could make some cancellations? I know that cotan is 1 over tan, but I also know that cotan is adjacent over opposite, or I know it's cosine over sine. And if you look at your identity page, you will see that. You're going to have to memorize those basic identities. So now I'm going to change cotan x to cosine x over sine x. And it's divided by 1 over sine x. Now I've done all the simplifying, I've done all the breaking down of the trig functions. I'm going to now multiply by a reciprocal, which is just an algebra skill. So we're going to go this way, and we're going to have cosine x over sine x multiplied by sine x, and that's over 1. Now my sine x is canceled, and this has simplified down to 1 value cosine x. And all this simplifying is going to be very important when we verify, and then even more so when we evaluate and solve our equations. All right, let's move on to example 4. All right, for example 4, we've got a couple of different identities. You need to look in your on your identity sheet for today, but you do need to memorize them. Whenever you see pi over 2 minus x or 90 minus x, we're talking about cofunctions. So take a look on your identity page at cofunctions. And when you see cotan 90 minus x or pi over 2 minus x, that's the same as tan x. Tan x. So this is really equivalent. I'm just rewriting, substituting it for its other value, what it's equal to. This is equal to tan x. And now we have tan x times cosine x. And now we're going to see what we can switch. Again, the basic identities, sine, cosine, are the last two that I would change. Sometimes I have to, but they're the last two I change. I think I would take tan, and I would rewrite tan. Okay, so now we're thinking again. I'm going to come over here and think. I have that little, so it's sort of a half smile while I'm thinking. Maybe it should be kind of slanted. I don't know. Anyway, so I'm thinking that tan is 1 over cotan, that doesn't help me, but it's also opposite over adjacent, which is sine, or y over x, which is sine over cosine. I think that might help me because it has a cosine in it. So I'm going to rewrite tan as sine x over cosine x times cosine x, and look what happens. My cosines cancel, and I'm left with sine x, which is a very simple form, and that would be my answer, or that would be simplified. All right, so it's really equivalent to, I wouldn't say it equals because it never equaled anything to begin with. We've just simplified it. Be really careful because we really aren't equal. All right, let's move on to example 5. Okay, I really like example 5. This uses our algebra skills, and you have to kind of look through the all the letters that you're seeing here. What you're looking for is that you have two things on this side and one thing on this side and a subtraction sign in the middle. We're simplifying, and the thing when we start to simplify equations is we use all of our algebra skills. And in this particular case, we're going to look to factor something out. What does this side have in common with this side? They both have sine squared x. So this is like, let's make sine n and secant c so that we'll use the n and the c's and see what would happen. So if you think of it this way as n squared times c squared minus n squared. If you think of it like this, so think of this if you have a hard time seeing through all the letters, and they both have n squared in them, so we would factor out n squared. And in our parentheses, n squared times something equals n squared c squared, that would be c squared, minus n squared times something equals n squared, that would be 1. So you think this is what you're thinking. Now, let's substitute everything back in. So n was sine, so we have sine squared x, in parentheses, c was secant squared x minus 1. And now we've done a lot there. The next thing we're going to worry about is we're going to think about, secant squared x minus 1. That should remind you about a Pythagorean identity. So now I'm going to come back over and think again. What do I know about Pythagorean identities? I know that 1 minus, let's see, that has to do with tangerine sections. 1 minus tangerine equals sections. So, if that's my Pythagorean identity and I want secant minus 1, then what's going to happen? I am going to keep my secant positive. I'm going to move my 1 over here, and I have negative tan, be careful, x equals secant squared x minus 1. So secant squared x minus 1 really is equivalent to this. I can replace this now with, be really careful, negative, and that's a tricky one, tan squared x. I can replace that with a negative plus. Well, it's not negative because these are plus signs. I'm sorry. A little tired today. I kept thinking, that doesn't look right. Sorry about that. It's 1 plus tangerine sections. All right, so tan, I can replace secant squared x minus 1 with tan squared x. So tan squared x is now this, and I have sine squared x multiplied by that. Now, again, I'm back to kind of where I was before. Now I can take tan squared x and take one of its fundamental identities. Tan is y over x, or sine squared x over cosine squared x. And we have sine squared x right here, which is going to give me 2 of them, squared x at the top. All right, so what happens? I'm going to multiply straight across, and when I do, I have sine to the 4th x. It's like a squared and times a squared would be a to the 4th. You add the exponents over cosine squared x. And that's simplified as we can get right now. Okay? It's down to 1 term. That's kind of what we're thinking. It's down to 1 term. All right, let's move on to example 6. All right, I also like this example, again, using some of our algebra skills. If we look at the top of this, secant squared x minus 1. That's like x squared minus 1. I want you to think that way. Look at the top one, and I want you to think. All right, I want you to think this is the same as x squared minus 1. X squared minus 1 is a difference of squares. It can be broken down to x plus 1 and x minus 1. So, x in this case is secant x. So, we can take that thought. You might need to slow this down a little and pause and think about what I just did. And we can take this thought based on this, and we can write it as 2 factors. It could be secant x, not squared anymore, plus 1, and secant x minus 1. And of course we would keep the bottom, which is secant x plus 1. And now we have a cancellation, and that was the whole point of doing this. So we can cancel these out, just like we would have before in algebra, and we're left with secant x minus 1, and that would be our final result. And that's simplified. Notice I don't have any equal signs anywhere because nothing is equal. This is just simplifying. When we get to 5.3, we'll have things equal, and we will actually solve. But we're not solving, we're simplifying right now. All right, our last example. All right, in this example, we're given a couple of things. We're given this equation that the square root of x squared plus 25, and then we're given that x is 5 tan x. So we're going to make our substitution. We're going to take 5 tan x, and we're going to substitute in for just the x part. So we're going to go square root, and in parentheses, we're going to have 5 tan x, and we're going to have a square on the outside plus 25. All right, this is a little tricky. All right, the next thing we're going to do is we cannot, and this is a really, you need to resist this. You're going to want to take the square root of 5 tan x squared and then plus the square root of 25. You can't do that. This is one term. If anything was being multiplied down here, you could take that out separately, but you can't take addition and subtraction out separately. So let's see what we can do. What if we go ahead and square this? If we square this, we're going to have 5 squared and we're going to have tan x squared. So let's do that next. So we still have the square root, and that would be 5 squared is 25, and then we would have tan squared x. Plus 25. Now, once again, we're looking at two sides of an equation underneath here, and we want to see what we could factor out. So they both have 25, so we're going to factor 25 out. So we're going to have the square root, and we're going to have 25 on the outside, and we're going to have tan squared x plus, we've already got the 25, so 25 times what would be 1. I've got to hurry because we're almost done here. Now we can separate them out. So now I can say the square root of 25 times the square root of 10 squared x plus 1. The square root of 25 is 5, so that just goes away. What we need to know here is, again, this is 1 plus tangerine sections